Okay, today I'm doing the last lesson of the review chapter. And we got to talk about having a review quiz coming up and that kind of thing. I'll talk about that later. Let's just focus on the last idea because I think I've got a pretty good way of explaining the last idea. The title. So you can take out a slice of paper, borrow a slice of paper from me, get out a pencil. It says solving equations, ... dealing with brackets. And we'll label that September I got the wrong thing on here. Just a second. I don't want that. There, now I feel better. September. What is it? 10th? Okay. And it looks like I'm doing a problem that doesn't have anything to do with brackets. Well, listen, friends. I know how to do 4 times 15 in my head, and it's not because I'm really smart. It's because I know something about 15 that really helps here. 15 doesn't have to be thought of as 15 if you don't want it to be. You can think of 15 as 10 and 5, and that changes the whole game. I'm not saying you should do this in your head. No, that's not what I'm saying. What I'm saying is it is possible to think of 4 times 15 as 4 times 10 and 4 times 5. And that gives you a chance to do it with mental math, or at least to get an estimate. Because I think I've broken it into 2 things that are actually fairly easy to do. I think a lot of people can do 4 times 10 in their head, given a couple of seconds. What is 4 times 10? 40. Okay, that's an easy one. So I've taken this 15 that was difficult to do multiplication in my head with, and I've broken it into 2 numbers that are fairly friendly. 40 is what 4 times 10 is. Then I'm stuck with 4 times 5. Now, I don't know. For some people, that's pretty easy. 4 times 5 is 20. Maybe it's not super easy for you. You got to go 5, 10, 15, 20. When that's all said and done, I now can look at this and go, oh, now I know what 4 times 15 is. I didn't try to count by 4s 15 times. I didn't try to count by 15s 4 times. I just said, what can I make this into friendlier numbers? Does this always work with numbers? No. There are some numbers that this doesn't make life all that much easier. But there are many numbers that this works well. So, answer, what do we got? 40 and 20? What's 40 and 20? 40 and 20. 60, okay? So I hope that was broken down. That idea can be used, and you were supposed to have done this last year, but if you don't remember, I've retaught it here. I could have done this question this way. I could have thought it as 4 times 10, 4 times 15 can be thought of as breaking the 15 into 10 and 5, and then multiplying the 4 by the 10, and then multiplying the 4 by the 5. Do you remember this last year? Teachers usually draw a lot of arrows to do this. Yeah? If you've got multiplication in front of brackets, and there's addition in there, you just have to what's called distribute. So I distributed the 4. Where else do we use the word distribute? When I gave you guys out a practice quiz or a handout, I distribute it. I hand it out to everybody. So distribution means everybody gets one. So everybody got multiplied by 4 here. Does this ring a bell? Is this sort of something you remember from grade 9? It's okay if it's not, because I'm going to practice it a few times before I try to use it, okay? Do you have any questions about that? All right. I should be done by then. It's not a long lesson, and it's the last lesson of the chapter. The review chapter. We're just reviewing grade 9 stuff. Okay. Is there any questions about this? Okay. Here's how it's used. I got these 3 questions to do for distribution. Here's my set of questions to help your memory. When there's a number in front of something like that, right beside it, what operation is that? When you've got a number in front of something, what operation are we talking about? We're multiplying. But we're multiplying by two things added, so this is the time to do distribution. So I say draw the arrows. On your quiz, I'll give a mark just for arrows. That's how important I think the arrows are. If you don't draw it, but you get the question right, you don't lose a mark, but you can get a mark just by going, oh, 4's got to get multiplied by x, and 4's got to get multiplied by 2. Now, multiplying 4 by x is actually real easy. You don't have to do anything. There's nothing to be done because we don't know what x is. So 4 times x is just 4x. I just write 4x. And then what's 4 times 2? Eight. 4 times 2, 8. So when you have brackets like that, multiply each one. Take out a slice of paper and start copying things down. That's the end of the lesson. Now I'm just going to incorporate it into other situations. Going to deal with some negatives and then put it into equations. So if you got that, like, okay, brackets, I multiply each one. Okay. This one, draw the arrows. 7 times x and 7 times the negative 8. When you're multiplying by a variable, there's nothing to do. 7 times x is just 7x. But 7 times negative 8, you might need some help. 7 times negative 8. Does anyone have their calculator? You got it? Good for you. You didn't use a calculator.
I just know 7 times 8 is 56 because 5, 6, 7, 8.
Oh, that's a clever way to remember that. That's a good one. That's a good one. One last time before we jump to equations. When you've got a number out front, draw an arrow for each number in there and multiply them in. Now this one's got a 2 in front of the x, so it's negative 2 times 2x. Well, don't worry about the x. We know we're talking about x's. What's negative 2 times 2? That can mess with your brain. But again, if negatives are an issue, continue to try to get right answers by using your calculator. But if I have a positive times a negative, I get a negative. So this is negative 2x. And then negative 2 times negative 10. Well, let's do the 2 times 10 first. 2 times 10 is 20. But is it going to be positive or negative? Negative times a negative. When you multiply a negative times a negative, do you get positive? Yeah, you get positive. Weird. That's weird that negative times negative is positive. That's one of the weirdest things in math you've probably seen so far, that should play out like that. How do you feel about this? Number in front of brackets, multiply it in. Okay? That's the last thing I'm adding this chapter. You're like, well, what's all the stuff that could be on this quiz? I got a practice quiz for you coming up, so you can practice and see what parts you're good at and what parts you still need to work on. Okay? Okay, even if you hadn't copied everything I've got down, even if you weren't copying at the start, you're going to want this. I know I'm playing games in this, and I might have annoyed you, and I'm sorry if I did. I really was trying to teach very, very well. This one is it, though. Mr. Todd's final. I'm not going to add any more. I'm not going to change it anymore. I'm not going to keep going on this. Awesome. Is that what I used? Is that the word I used? Awesome? Equation solving plan. Finally put it all together on one page. So you can ignore all the earlier ones, and I'm hoping you recognize everything I put on here. You're like, oh yeah, we talked about that. Oh yeah, we talked about that. 1. Distribute any brackets. So weird that the last thing I taught of the chapter is the first thing you should do in the equations. That's very strange that that's the way it worked out. But it's why my awesome plan kept changing, because I kept adding things into the recipe. If you want, it was like making chocolate chip pancakes. At the end, I was like, oh, chocolate chips, put that in first. Sorry, put chocolate chips in first. That's what happened here. Make sure you put the chocolate chips in. 2. Move variables to the left side. That's what we did at the end of yesterday's class. And yesterday I acted like, oh, that's the first thing you should do. And today I was like, actually, get rid of any brackets first. So it's brackets first, then move variables to the left side, and then use reverse. And please add this word here, because textbooks and later courses and other teachers will want you to instead of reverse, they'll want you to use the word inverse. Inverse is a better word, but we don't really need to call it inverse just yet. But we'll call it use reverse BEDMAS to do opposite operations. And I've really tried to shorten that down. When I first taught that, I did a lot more words in all that. But now, in the final version that we've practiced that, I hope that that's enough words. If it's not, you can go back to your old guides and fill in the gaps. Look, I'm on page 4 of 6 of my lesson. Now we're just going to practice it a couple times. Then we're going to talk about all the places you can practice. And then at least 1 word period tomorrow. Yes? At least 1 word period. Do you know you got a weird long weekend coming up? You got Friday off. PA day, and then Saturday, Sunday. So on the second week, so your first week was a 4-day week. Your second week's a 4-day week. So they're breaking you in slow. You know, you don't have to do a full week till next week. All right, friends, this is the most important thing I've written down so far. So I'm going to put a giant star beside it. Maybe you should put a star beside it too. As you're doing your practice to get ready for this quiz, you should look back on this, because this is the whole equation solving process in a nutshell. Written with as few words as I could. I don't know that I can do much better than that to make that shorter. Do you have any questions about that? Do you need more time? Who would like more time? We're good? Whoa. Look at these crazy ones. How many do I got? 3 crazy ones to do. On the first one, I encourage you to peek at the awesome plan we just wrote down. On the later ones, we'll try not to peek. What's the first step in Mr. Todd's awesome equation solving plan? Daniel?
Distribute any brackets.
Distribute any brackets. I'm trying to get you to use the fancy words. Distribute any brackets. And what do we draw on these to distribute? What's the shape I was encouraging you to draw?
Arrow.
Arrows, good. So, arrow, 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 arrow. So I know those look that equation looks very intimidating. But once you draw the arrows, you're like, hold on, it's going to get better if I multiply through. So 5 times x is 5x, and 5 times 4 is 20. 2 times x is 2x, and 2 times 16, 32. Okay, so again, when the numbers get too big for you, that's when you break out your calculator. Now, if you're right with me, and you've been catching up on, and you've been keeping up with some of the practice, by the time I get there, you're like, oh, that's the same as yesterday's now. There's an x on both sides, and that was step 2 of my procedure. Move all the x's to the left side. So this 2x, I don't want that there anymore. How do I get rid of 2x? What do I got to do to 2x to make it disappear? Oh, yeah, later on, I'll divide. Once it's just x's all on one side. When you're trying to get rid of that x over there, the only way I can get rid of it is with subtract. See how it's add right there, add 32? So I'm subtracting 2x from both sides. And if you have trouble with these at all, I encourage you to write it my way until you get used to it. Other teachers might not have liked the way I wrote it. But when you're first learning it, this is a great way to go. Okay, now get rid of the variables. Sorry, get rid of the variables on the right. And now back to my silly example. By the way, I need to tell you, when I use silly examples, am I trying to be funny so that you tell everyone Mr. Todd's so funny? Well, yeah, I like that. But also, when it comes to time for the quiz, sometimes the silly examples stick in your head a little bit better. So it's just me trying to put something silly in your head. Right? This says 5x minus 2x. If I have 5, trying to think of another word that starts with X. Xylophones. It's the only other thing I can think of. We didn't have to use Xavier's thing. If I have 5 xylophones and I take away 2 xylophones, I don't know why anyone would have 5 xylophones. I don't even know why somebody would have 1 xylophone, actually. But if I had 5 xylophones and I took away 2 xylophones, how many xylophones do I have? 3 xylophones. And if you're right with me, you're like, oh, now that I got rid of the x's on both sides, now it's a 2-step equation. That was the final step in my plan. Identify the operations and use reverse BEDMAS. This thing has multiply by 3 and add 20. Which one of the operations do we go after first if we're redoing reverse BEDMAS? Minus 20. Maybe you even want to use my new method here and just go, okay, I'm subtracting 20 from both sides. (32 minus 20 is 12. And now we're back to what Ava said. At the end now, to get rid of that 3 over there, we're going to divide. So x is 12 divided by 3. That's a very tough equation. That's a very tough equation to solve because it's got everything in it. And I'm going to go after one even tougher. Even tougher. I don't know if I'd put one this tough on a quiz. I'm going to do a real tough one just so that the sort of tough ones might seem easy to you. Okay? Toughest one of the chapter by far. Mr. Todd's equation solving, awesome equation solving plan says, step 1. Do you remember or do you have to peek? Daniel remembers. Distribute. He's in great shape. He knows 1/3 of the plan already. He's going to distribute any brackets if they're there. So we distribute here using the arrows and here using the arrows. So I get 3x minus 6 plus 5x equals 2x plus 6 plus 4x plus 2. What a mess. And I threw this one in. I didn't really teach this, what to do here. I didn't mention it. I threw it in because I'm like, oh, do you remember what to do in grade 9? Like if I have 3 xylophones over here and 5 more xylophones over there, I can gather those all up. Last year you would have called it collecting like terms. Or maybe you called it simplifying. And what's 3x and 5x? That's 8x. So I can tidy that up by collecting those 2 like terms. Over here, I can do it twice. I can put this 2x with this 4x, and that's 6x. And I can put the 6 and the 2 and make 8. Does that ring a bell? Just tidying them up like that? So you got multiple terms with x or multiple terms with numbers. You can just put them together. Now I'm ready for step 2. Step 2 says, what does step 2 say? Daniel.
Move variables to the left side.
Yeah, so I want to get rid of this 6x that's on the right side. So I'm going to subtract 6x. And I like writing it right there. You don't have to write it right there if you don't want. Again, as you move along, you might find that that's not very good form, but I like it. That gets rid of the 6x on the right, and I'm down to only 2x on the left. Now reverse BEDMAS. Hopefully you've done a little bit of practice on that, where you're like, okay, once we're down to two-step, I'm okay. That part's fine. I'm good at that. If the other parts you're not good at, well, that's what we're going to practice next. I got a worksheet that you practice a bunch of these. Okay, so opposite of subtracting 6. What's the opposite of subtracting 6? Adding 6, so I'm going to add 6 to both sides. And if you're having trouble with these, people who aren't having trouble, maybe I've already done the question. They've already done it on their page. But if you're having trouble, I've added a new little move here, this little add 6 up to the right here to go, if you're still, it's a little difficulties, this is a handy way to be able to see what's happening. 8 plus 6 is 14. And then the last step, as it often is divide. So I take 14 and divide by 2. And I get 7. You have questions? If that scares you, that question, I think it's nice to get to a scary one. You're like, well, I don't know if Ms. Tuttle asked one that hard, but that's as hard as things get here. You know? Let's go back and do one that's a little more like I would put on the quiz, okay? And we'll deal with that and make sure, maybe get some confidence back. Do you need more time here? Yeah, you do need more time. And then the next one is last example of the day. So if your brain is feeling a little fuzzy, last of my teaching for the day, and then I got to talk about the things you want to work on today and tomorrow. Still need more time? Yeah, that's fine. We'll take as much time as we need. Actually, sometimes I bring my cube with me. If I've written too fast, I can just play with my cube. Where did I put it? Did I bring it? I'm working on it. The other one will take me a little bit of time. During you guys' review periods, I might work on it a little bit. She's good now. Yeah, you're good. Okay, last one. Let's try and sort of do this together. Think in your mind, peek if you have to, what's the first step on this one? If you know what the first step is, draw in what you're going to need to draw and try and do the first line. But don't move on necessarily. Just wait. We'll sort of do it together. You'll do a step, we'll check it. You'll do a step, we'll check it. We'll try and walk you through this. Last one of the day. Make an effort here to think what the first step is and try to do it. Because we got lots of time. I'm going to be done by 10 to 1. Woo! Then I'll take my nap. Will you wake me up if I fall asleep? No. We'll just sneak out. I'm going to try and wait the exact right amount of time. Enough time that you could think and try just step 1. And then we will share and we will celebrate how unbelievably smart we are. I don't want to rush you. I want you time to think this over and see where you're at with all this. Do you need more time to decide and try the first step? You got it? Okay, so what is the first step here? Take a look at that chart I built. If you're unsure, when you're doing your homework, just look back at this. First step is distribute any brackets. And what do I have to do? What do I have to draw to distribute brackets? Arrows. So I put the arrows in here. Now check if you knew that and you drew the arrows in. Check if you got the right answers. And then argue with me. If you didn't get the right answers here, Raise your hand and argue with me and go, why? How come? What happened? Because we want to be able to get these right. Or frown at me. Throw something at me. How'd it go? Is this okay?
Yeah.
Distribution was okay. Okay, now we need someone smart because it's getting a little confusing. There's a lot going on here. We need somebody who's really on the case to go, now what? Yeah. Yeah, we don't want x's on both sides. Yeah, that really messes up. So then she says, get rid of the 3x by subtracting 3x from both sides. When I do that, now there'll be no x's on the left, or sorry, on the right. All the x's will be on the left. And so I got to do this little weird question, 7x minus 3x. 7 xylophones, subtract 3 xylophones. 4x. And if you're still having trouble with what goes next, that's okay. But for many people at this point, it may be that you're like, oh, well, once I get to there, then I'm good. Once I get back to a two-step equation, then I'm happy and I cruise right along after that. But if not, let's talk about it. We got to do reverse BEDMAS. We got to deal with multiply by 4 and subtract 14. Which one goes first? Do we do multiply or do we do subtract first? Deal with the subtract first because we're doing reverse BEDMAS, right? So I want to add 14. And again, for those of you who are having trouble with this is a great move. Very visual. Can really see what's happening there. And now we're back to a one-step equation. And what's the opposite of multiplying by 4? Divide by 4. And so I get 23 divided by 4. Now let's just punch that in your calculator and talk about it for a second. 23 divided by 4, what do you get? 5.75. And we got a lot to talk about. We're not going to rush it. If you write 23 over 4 and just leave it that, like, ooh, it was a decimal, I'll leave it as a fraction, I'm going to take it. I'm happy on the first review quiz. If you write the decimal, I'll be like, yeah, I'm going to take it. Well, we got some discussions to have about when would we rather the fraction and when would we rather the decimal. Maybe you have some opinions on that, but we got to talk about it because there's some situations where one might be better than the other. Any questions on that?